In the mesh current method, what we do is we identify currents as follows. I'm going to pick a clockwise direction, and we'll label this first mesh current I1, and I'll explain what that is in a moment in greater detail. And here's our second mesh current, I2. This current confined to the top mesh, and the other current is confined to the bottom mesh. And this current in the middle is the complicated current. Current I is actually I1 minus I2. See, the green current is flowing around the bottom in a clockwise direction. The red current is flowing around the top. If you look at the net current through the branch with the 2 ohm resistor, that current I will be the difference between the mesh currents. Alright, let's go through this example and we'll solve for those 2 mesh currents. Basic idea is that KCL already applied. We're already guaranteed conservation of current through the construction of the mesh currents. Alright, so let's solve for those currents I1 and I2. First step will be KVL around the top mesh. The equation looks like this. Sum of the voltage drops will be 0. Starting here, we'll get the voltage drops will be 1 times I1 plus minus 14 volts. That voltage drop is actually a rise, so it's minus plus 3 times I1. And finally we get a voltage drop of across the 2 ohm resistor of 2 times the current as labeled I, which is I1 minus I2. And that sums up to 0. We can gather our terms here. We get 6I1 minus 2I2 is equal to 14. Carrying on, we go to KVL around the bottom mesh. Again, the sum of the voltage drops equals 0. We'll start here. So the KVL equation is minus 8 plus 2. In this case, the voltage drop across the 2 ohm resistor traveling in this direction is 2 times I2 minus I1. Going to the next term, we have 4 I2. This is the voltage drop we're talking about. That current is flowing into the positive terminal, so that is a voltage drop in that direction. Finally, we have one more voltage drop across the 1 ohm resistor at the bottom. Collecting terms, we have minus 2 I1 plus 7 I2 is 8. At this point, we have our set of equations: equation 1, equation 2. Solving these manually for the moment. Let's try noticing the 6 and the minus 2 combined. So if I take 1 plus 3 times 2, we're going to get 0 I1s we'll get minus 2 plus 3 times 7, 21 I2s, and that's going to sum up to 14 plus 8 times 3. Simplifying, we get 19 I2s is 24 plus 14 is 38. So I2 is 38/19, which is 2. And substituting back, we get I1 is 14 plus 2I2 over 6, which gives us 3. Units of these two are both in amps. Let's switch over to IPython Notebook to verify the solution of these equations. So here are two example pieces of code using Python in which we solve the algebra. The first cell, we're using NumPy, creating a 2x2 matrix such that A times I equals B, and solving. In the second example, we're using SymPy, creating two symbols I1, I2, entering the equations and solving.